Hello, I'm Julian. I live in Graz with my wife and 2 kids, and I work for a company called Rainforest. And at Rainforest, we work on a product to automate quality assurance. You probably all know quality assurance. It's something that a lot of companies, even very big companies, still do manually. It's a kind of a pain, and we're trying to make it easier. And it's an awesome product, and it's fun to work on. I have many great colleagues, and actually we're hiring at the moment. So if you're looking for a job, we're almost entirely remote. So yeah, say hi. Right. In the summer of 1962, there was a NASA project, a pretty big milestone in the history of NASA. It was called the Mariner project, and the Mariner 1 was the first unmanned space vessel, and it was on a flyby mission to Venus to gather some info about the planet. And everything was going very well. Everybody was very excited at NASA. They launched a rocket, and after a couple of minutes, they noticed that something's wrong with the steering mechanism. So the rocket didn't respond to any of the steering signals. So after a couple of minutes, they had to destroy the rocket. And this was all because of a bug, a syntax error, actually, in a punch card. Yes, this is how people used to program. It's unbelievable. And this was probably one of the most expensive bugs in history. The whole project cost about $100 million to create. And yeah, that developer must have had a really shitty day. That brings me to the title of my talk. Writing software is really hard. And writing software that doesn't break is even harder. And that's a problem, right? Like, we're humans, we make mistakes. Now there's a bunch of ways in which we can protect ourselves from our mistakes. Quality assurance is one. What's another one?
Not coding.
Problem solved. End of the talk. Another one? Testing. Anything else?
Unit tests.
Unit tests, more specific, right? This is what the talk is about, actually.
Using language that can't break.
That's a good point. So there's a bunch of languages that implement type safety, right? That catches a few bugs. There's code reviews, right, which we all know and love. I'm going to talk about unit testing. All right, so for those who don't know, what are unit tests? Well, they're basically a way to verify that a unit, a piece of code, works as intended. So here you can see a very simple function. It adds A and B together. And down here you can see a unit test that checks if that actually returns what it should return. So why unit tests? Well, can I get a show of hands of how many people have never shipped a bug into production?
My girlfriend.
My mum.
My kid.
So none of the people here, we're all coders. We're all coders, right? Cool. How many here, can I get a show of hands of how many people unit test in this room? All right. Is it more back-end unit tests? Show of hands. Front end? All right, quite a few. Impressive. So back in the day, JavaScript was this language that, you know, it was a scripting language. You could fancy up your form or like put a nice little animation on your web page or something like that. That was the time when we were called webmasters, right? Now JavaScript has matured, and it's matured into from a scripting language into an application language. It's like we build complex applications on the front end with JavaScript, and on the back end, right? We use JavaScript on the server side as well. So that's why unit testing is becoming ever more important, because it's our kind of first line of defense against our own mistakes. Right, so the problem is that a lot of people still don't unit test because, well, a couple of things. One is that in our community, unit testing is perceived to be this kind of elite technique that only the best use or something. And there's tons of jargon and lots to learn, right? Lots of different contexts. People get very religious about unit testing, whether it's TDD or BDD and so on and so forth. What to test and what not. Actually, unit testing is fairly trivial, and I'm going to show you how trivial that is. So basically, what we're going to do is we're going to fix the marina. Right. So I've traveled back in time to 1962. I've inherited this code base from Joe, my fellow developer, and it's obviously not working. So let's see what's not working. Well, okay, it's launching, right? It's launching. What happens if I press the left button? Yeah. Doesn't really look like steering left to me. The right button doesn't do anything. Right, so it's obviously broken, right? Okay, yeah, well, somebody thought it was working and they shipped it into production, and that's why they lost $100 million, right? We don't want that. So we're going to do something to fix that. And the first thing we're going to do is write some unit tests. So just to give you a heads up, like I'm not using any kind of framework in here. I'm using jQuery actually. I'm not using jQuery at work, but like for this example, to not distract anybody, I'm just using jQuery. So what we're doing here is we're also using ES6 syntax. So I'm importing the jQuery module. I'm importing the rocket control module and a render rocket interface method, which basically renders this interface. The bit down here, the launch button and the other two buttons. Right, so describe is just a way of organizing your unit tests. That's pretty much it. And I'm gonna, well, write a couple of unit tests here. So basically what we want to test is what we want to work. So we obviously want the rocket to launch. We want the rocket to steer right when the right button is pressed, and we want the rocket to steer left when we press left. So it launches, and this is pretty much like you just write plain English in here. Launches the rocket when the launch button is pressed. Right. Then it steers right when the right button is pressed. And it steers left when the left button is pressed. Right, now I'm going to do something magical. I'm going to start my test runner. And we're going to see the output of those tests. Right, so what do we see here? We see those 3 sentences. They're basically, right now, we're not testing anything. We're just, these are just assertions, basically. And now we're going to implement the actual test. I'm going to just use fat arrow functions in here. Right, so we first want to spy on a method. So spying is a way of hooking into a function to later on test if the function has been called. So what I'm going to do is I'm going to spy on the launch rocket method of the rocket control object. Then I'm going to simulate a button click. Launch rocket. Whoops. Click. And then I'm going to write an expectation or an assertion. That's what it's called as well. And that's going to be expect rocket control launch rocket to have been called. Right, when I save this, we can see that this actually works. And it's true, like when we press launch, it launches. Hooray. So that assertion is true. Now let's look at the other ones. It steers right when the right button is pressed. So a lot of the time when you write unit tests, you'll find that you can copy-paste stuff. And that's what I mean with it's fairly trivial code that you're writing when you write unit tests, because really a lot of the times you're repeating yourself. Right, so I'm going to test if the steer right method is called. That is obviously not called, and that's why we get an error. So our test runner here says spy was not called, which is this. And I'm going to do the same for the left button. And I'm going to copy and paste stuff. And that obviously doesn't work either. So number 1 is passing, and the other 2s aren't. Right, so now we're going to look at the actual implementation and try to fix things. No. No. Right. Lovely win. Right. So something's wrong in this interface. Let's figure out what. Steer right isn't working. Can you see why?
There's a typo.
There's a typo. Right.
And the function is not called, actually.
Boom. Does this work? Yay, we have 2 passing. Okay, it steers right now when the right button is pressed. Let's have a look at left. Okay, what's happening here? Right. It's the wrong direction. Okay, now all tests are passing. Right, so now I've written these tests, and what I've done is I have documentation now. Like in the test, I can actually see what the interface should do. So we're developers, we never write documentation, right? But sometimes we write unit tests. So when I want to know what an open source module actually does, I usually look at the unit tests. And the same thing goes for when my teammate does something. He writes unit tests. I can actually look at the specs, at the unit test suite, and figure out what it's supposed to be doing. And the other thing I've done here is I've locked in the behavior. So if somebody else in future comes along and refactors this code, they'll know that they've broken it. They'll get notified, right? So now Joe comes in and goes, hold on, this isn't modular at all. We need to put some composition in there, right? So let's write a function. Whoops. Function. Good old syntax highlighting. Let's write a function for the launch button. Let's write a function for the write button. Oop, we need that one. And for the left button. Right. And now we're going to move the events, the event handlers as well. Oops. There you go, lovely Vim. And obviously we also need an L. We're going to return that. And we're going to do the same for the others. And I can't be bothered to copy and paste everything again, so I'm going to actually do that. I'm going to do that this. Right, so this looks all right. Now I just need to append these. Looks good. Okay, but the tests are failing. Let's have a look. First of all, they're in the wrong order. But it should work, right? It's not working. Can anybody see why? Like, I'm rendering them, obviously. They wouldn't otherwise be on the page, right? Anybody, any idea? What's wrong here?
Isn't the, you didn't need to change the click selector?
How?
Yeah, to use to test the element, just l.click.
That's it. That's it. And that's exactly the sort of thing, exactly the sort of mistake that happens and gets shipped into production, right? Because it's like a little detail that you can easily overlook. And our unit tests, thankfully, have prevented us from making that mistake. And this happens all the time. And it's why me and all my teammates thank God that there's unit testing in this world. So right, so this is working now. But what if Joe actually hasn't got his... Sorry?
It's still wrong. It's working, but it's still wrong.
How is it still wrong?
Because the buttons are rendered wrong. There's a
Let's check. Let's check. Looks right to me.
Yeah, look at the code. It's wrong. Line 14. Line 14. You have a greater sign too much. And line 20.
No, that's
No, but that's on purpose.
that's this. That's the error.
It's not a statement. Okay, so
That's right. Yeah, it's just me being cheap.
okay. Yes. Okay.
So right, what if Joe hasn't got his test runner running, and actually makes this mistake? Oop. Nope. And goes, fixed it, fixed Julian's shit. And it's much better, it's much more modular. Right, let's push this. What will happen? Can anybody guess? Yeah, there's a Git Hook which automatically runs the unit test suite and prevents Joe from wasting another $100 million. So, right, let's fix this. Joe goes, okay, fine. Also, like, Joe's a nice guy. I want Joe to be able to collaborate with me. So, if unit tests are the key to doing that, well, there you go. Right. Okay, so let's push this. Does it go through? Yes, it does. Now, Joe wants to actually get his change deployed, and he goes to GitHub, sees that GitHub Smart, sees that there's a new branch. And creates a pull request. And now, the nice thing about unit tests is you can use them in so many ways. And one way in which we at Rainforest use it is continuous integration and continuous deployment. So what that means is continuous deployment means that only if your unit tests pass, only if all the tests pass, you can actually deploy stuff. So you can see here I've got Travis hooked up. Travis is a service that you can use to make continuous integration happen. And what it does is it runs your unit test suite on a Unix box somewhere and integrates with GitHub. And that's how I get this whole thing here. And I can actually look at this. Nope. Can I not look at this? Details? Right, there you go. It runs the unit tests like on my laptop, and it tells me that everything's okay, and I can merge. And I'm just going to show you an example of a pull request on the Rainforest front-end repository. This actually failed Let's see why it's failed. So we use Circle CI, which is another one like Travis. And we actually also use Rainforest has continuous integration as well. So we use that as well. Yeah, it's pretty good. So, right, unit tests. To recap, they're also documentation. They encourage you to write better code. Basically, when I'm writing codes, I think about, how would I test this? And this automatically kind of brings me into this headspace where I think, hey, let's use composition. Because if I have small functions that each do 1 bit, single responsibility principle, right? It's easier to understand, it's easier to test. Right, great. And that's why also like functional programming in JavaScript makes a lot of sense, a lot more, especially for unit test. It's kind of, it's like the pit of success, if you've heard that phrase. You like fall into, you kind of being forced by your own practice to write better code. It gives you confidence in your code base, in the code you've written, and that it won't break in future because somebody else comes along, refactors your code, and sees, hey, this actually breaks the functionality, so I need to change my code, I need to fix it. So, yeah, unit tests provide confidence, also from your users in your product, because you'll ship less bugs, basically. Now, when should you test? Well, I usually ask myself, what do I not want to break, basically? So, and I'll test that. I might, like, sometimes I'll leave out implementation details and just focus on the bigger picture. So if I, like, obviously, this example was oversimplified, and with a real rocket, there's a lot more going on to launch it, right? So, sorry?
It's rocket science, after all.
It's rocket science. Right. So yeah, it's like, that's kind of the question I ask myself when I want to test something. So unit tests aren't a magic bullet after all. You can have 100% code coverage, and your app might still fail because some bugs kind of live at the edge of your application, like between the functions, between the different systems that integrate to work together as your app, basically. They can also be badly written, of course. This is why we have code reviews. Right. So other than unit tests, you should consider functional integration tests, and probably also some manual QA. It depends, really. Like, if you're working on a hack project that you do for yourself, you might just want to forget unit tests and get it out of the way, right? Especially if it's something trivial. But if you're shipping code to hundreds of users, then you're gonna save yourselves a couple of headaches if you unit test. Right. So, thanks, guys. Now, check us out. And if you have any questions about Rainforest or unit testing or anything else, or want to work for Rainforest or something, get in touch. Thanks, guys.
Thank you for watching this talk. Down below, you can find our channel ViennaJS, where you can find a lot of different videos about front-end and back-end JavaScript, and feel free to subscribe.